Here's something that will mess with your head. The Milky Way is one of the largest galaxies in the entire observable universe. I'm not exaggerating. Our galaxy is bigger than 95% of all galaxies that exist. We're living in a cosmic giant. But here's where it gets weird. At the same time, when you zoom out far enough, our massive galaxy becomes so small it's almost nothing. Less than a grain of sand on a beach. Less than a single atom in your body. Tonight, I'm going to show you how both of these things can be true at the same time. And by the end, the way you see that band of light across the night sky will never be the same. Before we start, if you're into these cosmic deep dives, hit that subscribe button. It genuinely helps. And now, let's blow your mind. Let's start with what we know. You've heard the Milky Way is big. And yeah, it is. But I don't think most people realize just how big. The Milky Way stretches 100,000 light years from edge to edge. Let me put that in perspective. Light travels at 186,000 miles per second. That's fast enough to circle Earth 7.5 times in 1 second. And even at that insane speed, it takes light 100,000 years to cross our galaxy. If you somehow left one edge of the Milky Way right now traveling at light speed, by the time you reach the other side, 100,000 years would have passed. Modern humans have only existed for about 300,000 years. You'd experience a third of all human history just crossing our galaxy. Inside this vast structure, we have somewhere between 100 billion and 400 billion stars. The exact count is fuzzy because counting stars in a galaxy you're inside of is like trying to count all the trees in a forest while standing in the middle of it. Most are hidden behind dust, obscured by distance, or just too faint to detect. Our sun is just one of these billions. It sits about 26,000 light years from the galactic center, tucked into a minor spiral arm called the Orion Spur. We're not at the center of anything important. We're in the cosmic suburbs, in a relatively quiet neighborhood, where stars aren't too densely packed and supernova explosions are rare enough that life could develop without getting sterilized by radiation. Every single star you can see with your naked eye on a clear night belongs to the Milky Way. Every constellation ancient humans created, every shooting star you've ever wished upon, all of it is part of this one structure. For most of human history, we didn't even know anything existed beyond our galaxy. The Milky Way was the universe. That's it. That's all there was. But here's where things start to get interesting. When I tell people the Milky Way is one of the largest galaxies in the universe, they usually don't believe me. Because we hear about these massive galaxies out there, right? Galaxies with 1 trillion stars, giant elliptical galaxies millions of light years across. Those exist. We'll talk about them. But here's what most people don't realize. Those giant galaxies are freaks. They're the exceptions, not the rule. The overwhelming majority of galaxies in the universe are tiny. We're talking dwarf galaxies with just a few billion stars, sometimes just a few million. Galaxies only a few thousand light years across. Let me give you some real examples from our cosmic neighborhood. The Large Magellanic Cloud orbits the Milky Way. It contains about 10 billion stars and stretches about 14,000 light years across. That sounds impressive until you realize the Milky Way is 7 times wider and contains up to 40 times more stars. The Small Magellanic Cloud is even smaller, about 7,000 light years across with just a few billion stars. That's tiny compared to us. And these aren't even the smallest. There are ultra-faint dwarf galaxies that contain only a few thousand stars. Sagway 1, discovered in 2006, has roughly 1,000 stars. That's not a typo. 1,000 stars. It's barely a galaxy at all, more like a large star cluster that happens to be gravitationally bound. These dwarf galaxies are everywhere. They're incredibly common. For every large galaxy like the Milky Way, there are probably hundreds or thousands of dwarf galaxies. The Milky Way itself has about 50 known satellite dwarf galaxies orbiting it. 50 smaller galaxies just in our immediate neighborhood, all tinier than us. When astronomers survey the universe, dwarf galaxies are what they find most often. The universe is absolutely packed with them. They outnumber large galaxies by a massive margin. Studies estimate that about 95% of all galaxies in the observable universe are smaller than the Milky Way. Think about that. 95%. If you randomly selected 100 galaxies from across the universe, 95 of them would be smaller than our home. That means the Milky Way sits in the top 5% of galaxies by size. The top 5%. That's not average. That's not typical. That's exceptional. We're not living in some mediocre, middle-of-the-pack galaxy. We're living in one of the giants, a massive spiral that most galaxies will never match in size. Most galaxies are small, faint, and unremarkable. The Milky Way is none of those things. So when someone tells you the Milky Way is one of the largest galaxies in the universe, they're not being poetic. They're being literal. By any statistical measure, our galaxy is huge compared to what's out there. But, and this is important, when you compare the Milky Way to the very largest galaxies, the picture changes completely.
Let me introduce you to some galaxies that make the Milky Way look small. IC 1101. This is one of the largest galaxies ever discovered. It's a supergiant elliptical galaxy sitting at the center of a galaxy cluster about 1 billion light-years away. IC 1101 is approximately 6 million light-years across. Let me repeat that, 6 million light-years. The Milky Way is 100,000 light-years across. IC 1101 is 60 times wider. If the Milky Way were a penny, IC 1101 would be a large pizza. This galaxy contains about 100 trillion stars. That's roughly 250 times more stars than the Milky Way. This single galaxy has more stars than many entire galaxy clusters. Here's something wild. If you replaced the Milky Way with IC 1101, Andromeda wouldn't be our neighboring galaxy anymore. Andromeda sits 2.5 million light-years away. It would actually be inside IC 1101's boundaries, completely engulfed. But IC 1101 is not normal. It's exceptional. It's one of the largest galaxies we've ever found. Galaxies like this are incredibly rare. Then there's M87, a supergiant elliptical in the Virgo cluster. You might have heard of M87 because it was the first galaxy where we directly imaged a black hole, that famous orange and black image from 2019. M87 is about 120,000 light-years across, similar to the Milky Way's diameter, but it contains around 1 trillion stars, compared to our few hundred billion. And here's the kicker. M87's central supermassive black hole has a mass of about 6.5 billion times our Sun. The black hole at the center of the Milky Way, Sagittarius A, is only about 4 million solar masses. M87's black hole is more than 1,600 times more massive. It's a monster. There's also NGC 6872, sometimes called the Condor Galaxy. It's a spiral galaxy about 400,000 light-years across, 4 times the diameter of the Milky Way. From certain angles, it looks rectangular rather than spiral, earning it the nickname the Box Galaxy. And Malin 1, discovered in 1986. This is a giant, low-surface brightness spiral galaxy, about 650,000 light-years across, more than 6 times wider than the Milky Way. The interesting thing about Malin 1 is that it's very faint. Even though it's huge and contains lots of stars, those stars are spread out over such a large area that the galaxy is extremely hard to see. It took until the mid-1980s to discover it, despite being relatively nearby in cosmic terms. These galaxies show us that while the Milky Way is large, there are definitely bigger spirals out there. But here's what you need to understand. These giant galaxies are rare, very rare. For every IC 1101, for every M87, for every supergiant elliptical, there are thousands upon thousands of galaxies smaller than the Milky Way. The giant ellipticals are particularly impressive. Galaxies like A2261 BCG sitting at the center of a galaxy cluster about 3 billion light-years away. It's roughly 2 million light-years across and contains about 10 trillion stars. These giants typically formed by cannibalizing other galaxies. They sit at the centers of galaxy clusters where their gravity has allowed them to consume many smaller galaxies over billions of years. They're cosmic snowballs that rolled through space gathering mass. So yes, compared to these absolute monsters, the Milky Way is smaller. But let's be clear about the comparison we're making. For every IC 1101, for every M87, for every supergiant elliptical, there are thousands upon thousands of galaxies smaller than the Milky Way. The giants are outliers. They're exceptions. They're the freaks of the cosmic zoo. If you gathered 1,000 random galaxies from across the universe, probably 950 of them would be smaller than the Milky Way. Maybe 40 would be roughly similar in size, and maybe 10 would be larger, with only 1 or 2 being dramatically larger, like IC 1101. The Milky Way isn't in the top 1%, but it's comfortably in the top 5%, and that makes it large, genuinely large by any cosmic standard. Most galaxies will never have as many stars as the Milky Way. Most galaxies will never be as wide. Most galaxies are small, faint dwarfs. The Milky Way is exceptional. It's one of the big kids on the cosmic playground. But now let's zoom out, because this is where the Milky Way starts to shrink. The Milky Way isn't alone. We have neighbors, lots of them. The closest large galaxy to us is Andromeda, sitting about 2.5 million light-years away. Andromeda is actually bigger than we are. It contains around 1 trillion stars, more than twice what we have. It's also about 220,000 light-years across, more than twice our diameter. Andromeda is also on a collision course with us, but don't panic. That won't happen for another 4.5 billion years. And when it does, it'll be more of a merger than a crash. The distances between stars are so vast that actual collisions between individual stars are incredibly unlikely. The two galaxies will pass through each other, their shapes distorting until they eventually settle into a single large elliptical galaxy. Some astronomers have already nicknamed this future galaxy Milk Cometa or Milkdromeda. Then there's the Triangulum galaxy, M33. It's the third largest spiral in our neighborhood, containing about 40 billion stars and stretching about 60,000 light-years across, less than half the size of the Milky Way. These galaxies, along with about 50 others, form what astronomers call the local group. It's basically our cosmic neighborhood. Most of the galaxies in the local group are small dwarf galaxies with just a few billion stars or less. The Milky Way and Andromeda are the two dominant members, the big siblings in a family of smaller galaxies that orbit around them or float between them. The local group spans about 10 million light-years across. That sounds massive, and it is. But here's where things start to put our galaxy in perspective. The local group is just one tiny cluster in a much, much larger structure. The local group is part of something called the Virgo Supercluster. A supercluster is exactly what it sounds like. It's a cluster of galaxy clusters. Instead of individual galaxies, we're now talking about groups of galaxies, all gravitationally bound together in an enormous structure. The Virgo Supercluster contains at least 100 galaxy clusters and groups. One of the largest is the Virgo cluster itself, sitting about 54 million light-years from us. The Virgo cluster contains somewhere around 1,000 to 1,200 galaxies. Some of these galaxies are enormous, far bigger than the Milky Way. The Virgo supercluster as a whole contains about 100 trillion stars spread across roughly 110 million light-years.
Let me put that in perspective. Remember how the Milky Way seemed big at 100,000 light-years across? The Virgo supercluster is 1,100 times wider. Our entire galaxy, with all its hundreds of billions of stars, is just a tiny speck in this larger structure. If the Virgo supercluster were the size of a city, the Milky Way would be smaller than a single house in that city. Actually, it would be more like a room in that house, maybe even just a piece of furniture in that room. And we're not done, not even close. In 2014, astronomers discovered something even bigger. They found that the Virgo supercluster itself is just a small part of an even more massive structure. It's called Laniakea. The name comes from Hawaiian and means immeasurable heaven, which is fitting because Laniakea is almost incomprehensibly large. Laniakea is a supercluster of superclusters. It contains about 100,000 galaxies spread across 520 million light-years. 520 million light-years. All of these galaxies, including ours, are slowly moving toward the center of Laniakea, drawn by the combined gravity of all that mass. The Milky Way isn't just sitting still in space. We're falling, along with everything else in Laniakea, toward a region called the Great Attractor. Now here's where the scale really starts to mess with your head. If you shrunk Laniakea down so that the Milky Way was the size of a grain of sand, Laniakea itself would be about as big as a large room. We've gone from thinking our galaxy is everything to realizing it's less than a speck of dust in a structure so large it defies easy comprehension. The Milky Way, one of the largest galaxies in the universe, is nothing compared to Laniakea. And we're not done zooming out. Laniakea is huge, but it's still just one supercluster among many. When we zoom out even further, we see that the universe is filled with these structures. Superclusters separated by vast voids, enormous empty regions of space where very few galaxies exist. The universe at the largest scales looks like a cosmic web. Filaments of galaxies stretching across billions of light-years, connected by threads, separated by enormous empty spaces. Let me tell you about some of these structures because they make even Laniakea look small. The Sloan Great Wall was discovered in 2003. It's a wall of galaxies that stretches about 1.37 billion light-years across. It's located about 1 billion light-years from Earth and contains tens of thousands of galaxies. To put that in perspective, if the Milky Way were the size of a grain of rice, the Sloan Great Wall would be longer than 10 football fields placed end to end. This structure was discovered by mapping the three-dimensional positions of galaxies. When you plot where galaxies are in space, not just where they appear on the sky, but how far away they are, patterns emerge. Galaxies aren't randomly distributed. They cluster along filaments and walls, surrounding vast empty voids. The Sloan Great Wall is one of these walls. It's a sheet of galaxies, relatively thin, but extremely long and wide. Think of it like a cosmic membrane stretching across more than 1 billion light-years of space. What's remarkable about the Sloan Great Wall is that it was completely unknown until recently. Many of those galaxies had been observed decades earlier, but we didn't know they formed a coherent structure until we had good distance measurements. Then there's the CFA2 Great Wall, discovered in 1989. This is another filament of galaxies, about 500 million light-years long, 200 million light-years wide, and 15 million light-years thick. The Virgo supercluster, which contains the Milky Way, is actually part of this structure. So in a sense, we live on one of these walls.
But the Milky Way is just one tiny galaxy among tens of thousands that make up the wall. These discoveries fundamentally changed how astronomers think about the universe's structure. In the early 20th century, galaxies were thought to be more or less randomly distributed in space. Sure, there were clusters, groups of galaxies bound together by gravity, but those clusters were thought to be isolated islands in an otherwise empty void. By the late 19th century, it became clear that this wasn't true. Galaxies aren't randomly distributed. They form a cosmic web with filaments and walls surrounding voids. This cosmic web structure is thought to be a result of how the universe evolved. In the very early universe, tiny density fluctuations existed in the distribution of matter. Some regions were slightly denser than average, others slightly less dense. Over billions of years, gravity amplified these fluctuations. Denser regions attracted more matter, becoming even denser. Less dense regions lost matter to their surroundings, becoming voids. The result is the cosmic web we see today. Filaments of galaxies stretching across hundreds of millions or billions of light years, surrounding voids that are nearly empty. And the Milky Way is just one galaxy in this vast web, sitting on a filament, part of a structure that's far, far larger than itself. Computer simulations of the universe's evolution reproduce this cosmic web structure beautifully. By starting with the conditions that existed shortly after the Big Bang and letting gravity do its work, these simulations show the formation of filaments and voids that look remarkably similar to what we observe in the real universe. These simulations also show that the cosmic web is not just made of visible matter, stars and gas. It's primarily made of dark matter. Dark matter forms the scaffolding, the underlying structure. Visible matter falls into this scaffolding, collecting in the densest regions where it can form galaxies and stars. So when we talk about structures like the Sloan Great Wall, we're really talking about a concentration of dark matter that happens to contain tens of thousands of galaxies. The galaxies are just the visible parts, like lights on a Christmas tree. The tree itself, the structure that holds everything together, is made of dark matter. The Milky Way sits in this cosmic web, held by dark matter, connected to other galaxies through filaments of dark matter. We're part of something much larger than ourselves, and that something is incomprehensibly vast. If superclusters and cosmic filaments show us how matter clusters together, then voids show us how empty the universe really is. Between the filaments of the cosmic web are vast empty regions where very few galaxies exist. These aren't completely empty, but the density of galaxies is much, much lower than in the surrounding regions. The largest known void is the KBC void, named after astronomers Ryan Keenan, Amy Barger, and Lennox Cowie. This void is roughly 2 billion light-years across. 2 billion light-years. Inside it, there are very few galaxies. Think about that scale for a moment. If you were somehow transported to the center of this void and looked out in any direction, the nearest significant galaxy clusters would be about 1 billion light-years away. At that distance, even a giant galaxy would appear as just a faint smudge, barely visible even with powerful telescopes. Our Milky Way could fit across the width of the KBC void 20,000 times. 20,000 times! The entire local group would be a barely visible speck. Even Laniakea, that immense supercluster containing 100,000 galaxies, would fit across the KBC void less than 4 times. These voids make up about 80% of the universe's volume. Most of space is empty. The galaxies, superclusters, and filaments occupy only a small fraction of the total volume. It's like the universe is a vast ocean with islands of matter scattered throughout, and the Milky Way is a single grain of sand on one of those islands. There are other massive voids too.
The Botez void, sometimes called the Great Void, is about 330 million light-years in diameter. It was discovered in 1981 and contains very few galaxies for its size. When it was first discovered, astronomers found it so empty they initially thought their data must be wrong. The Eridanus supervoid is another enormous empty region, about 1 billion light-years across. Some scientists have suggested it might be responsible for a cold spot observed in the cosmic microwave background, the afterglow of the Big Bang. These voids are fascinating because they tell us something important about the universe's structure. The fact that voids exist, that matter has clumped into filaments, leaving vast empty spaces, is a direct result of how gravity has shaped the cosmos over 13.8 billion years. But they also remind us of something humbling. Most of the universe is nothing, empty space. The galaxies, for all their grandeur, occupy only a tiny fraction of the cosmos. And our Milky Way? It's one galaxy on one filament, surrounded by voids that dwarf it completely. Now, let me tell you about the largest known structure in the entire observable universe. It's called the Hercules Corona Borealis Great Wall, and it's absolutely mind-blowing. This is a galactic filament, basically a long string of galaxy clusters, that stretches across about 10 billion light-years. 10 billion light-years! To put that in perspective, the Milky Way is 100,000 light-years across. The Hercules Corona Borealis Great Wall is 100,000 times larger. If you traveled at the speed of light, it would take you 100,000 years to cross the Milky Way. It would take you 10 billion years to cross this structure. That's more than 70% of the age of the universe itself. The universe is only 13.8 billion years old. This structure is almost as old as time itself. This structure contains billions of galaxies. The total mass is almost impossible to comprehend. And yet, even this enormous structure is just one part of the universe's cosmic web. There are other giant walls and filaments, slightly smaller, but still staggeringly large. Here's where it gets really interesting, though. The existence of structures this large actually created a problem for cosmologists. According to our understanding of how the universe evolved, there shouldn't be enough time for structures this large to form. The universe is only 13.8 billion years old. Gravity works slowly. It takes time for matter to clump together into galaxies, and even more time for those galaxies to cluster into groups and superclusters. Computer simulations of the universe's evolution predicted that the largest structures should be no more than 1.2 billion light-years across. The Hercules Corona Borealis Great Wall is roughly 10 times larger than that. Its existence suggests that either our models are wrong or incomplete, or that the universe is stranger than we thought. Scientists are still trying to figure this out. Some think there might be aspects of dark matter or dark energy that we don't understand yet. Others think the structure might not actually be a single connected filament, but rather several structures that appear connected from our perspective.
Either way, the takeaway is clear. The Milky Way, sitting in its little corner of the Virgo supercluster, is utterly insignificant compared to structures like this. Our entire galaxy could be copied 10 billion times and strung end to end, and it would just barely match the length of one cosmic filament. Think about what that means for a moment. The Milky Way, this massive structure containing hundreds of billions of stars, one of the largest galaxies in the universe, is nothing compared to the Hercules Corona Borealis Great Wall. If the Milky Way were a single atom, the Hercules Corona Borealis Great Wall would be larger than a human body. Actually, that's probably understating it. This is the scale we're dealing with. This is how small even a large galaxy becomes when you zoom out far enough. Let's zoom out one more time, all the way out. The observable universe, the part of the universe we can actually see, is about 93 billion light-years across. You might wonder, if the universe is only 13.8 billion years old, how can we see things 93 billion light-years away? Shouldn't the observable universe be only about 27.6 billion light-years across? The answer has to do with the expansion of the universe. Light from distant galaxies has been traveling toward us for billions of years, but during that time, space itself has been stretching, carrying those galaxies even farther away. So a galaxy that emitted light 13 billion years ago has moved much farther away during the time its light has been traveling toward us. By the time that light reaches us, the galaxy might now be 46 billion light-years away. That's why the observable universe is about 93 billion light-years across. It's the maximum distance from which light has had time to reach us, accounting for the expansion of space. Within this observable universe, astronomers estimate there are about 2 trillion galaxies. 2 trillion. Let that sink in for a moment. And the Milky Way is just one of them. Not a special one, not a particularly large one in the grand scheme, just one among 2 trillion others. If we tried to represent this visually, if we made a scale model where every galaxy was represented by a single grain of sand, we would need enough sand to fill several Olympic-sized swimming pools. The Milky Way would be one grain in that vast collection, indistinguishable from all the others. But here's something that should really blow your mind. The observable universe is just what we can see. The actual universe is almost certainly much larger. It might even be infinite. We have no way of knowing because we can't see beyond the observable limit. The light from anything farther away simply hasn't had time to reach us yet. Think about what that means. The Milky Way, sitting in its little corner of space, is part of an observable universe that contains 2 trillion galaxies. But that observable universe might just be a tiny fraction of the total universe. If the universe is infinite, then the observable universe, vast as it is basically nothing. 0% of infinity is still 0. And our galaxy? In an infinite universe, the Milky Way isn't just small, it's infinitesimally small. It's less than a grain of sand on a beach. It's less than an atom in the Earth. It's so small that there aren't really adequate comparisons. Some theories in physics go even further. They suggest that our universe might just be one of many in a multiverse. These ideas arise from attempts to understand quantum mechanics and cosmic inflation, the rapid expansion that occurred in the first fraction of a second after the Big Bang. According to eternal inflation theory, the Big Bang wasn't a single event. It's happening constantly, creating bubble universes that spawn more bubble universes. Our universe would be just one bubble in an infinite foam of universes, each with potentially different laws of physics. In some versions of quantum mechanics, every time a quantum event has multiple possible outcomes, the universe splits and all outcomes occur in different branches. This would create an infinite number of parallel universes, one for every possible outcome of every quantum event. Now, these ideas are speculative. We have no way of observing other universes, so these theories are hard to test. But they're taken seriously by many physicists because they arise naturally from well-established theories. If the multiverse exists, then our universe, already unimaginably large, is just one of many. And the Milky Way? It becomes even more insignificant. Not just small compared to our universe, but small compared to an infinite collection of universes. This is the ultimate zoom out. This is where the Milky Way, one of the largest galaxies in existence, becomes truly, utterly tiny. So let's take a step back and think about what we've discovered. We started by talking about the Milky Way, our home galaxy, a spiral containing hundreds of billions of stars. It seemed big, and it is big by most standards, but then we compared it to the local group, to the Virgo Supercluster, to Laniakea,
to the cosmic web of filaments and voids. We compared it to giant galaxies like IC 1101 that are 60 times larger. We compared it to structures like the Hercules Corona Borealis Great Wall that are 100,000 times larger. We compared it to the observable universe that contains 2 trillion galaxies and possibly to a total universe that might be infinite. At every step, the Milky Way got smaller. Not physically smaller, it's still 100,000 light years across, but smaller in significance, less special, more ordinary. This is a humbling realization, but it's also liberating. For most of human history, we thought we were the center of everything. We thought the Earth was the center of the universe, with everything revolving around us. Then we learned that Earth orbits the Sun. Then we learned the Sun is just one star among many. Then we learned those stars form a galaxy. Then we learned our galaxy is one among many. Then we learned those galaxies form superclusters. Then we learned those superclusters are just small parts of a much larger cosmic web. At each step, we've been knocked down a peg. We're not central. We're not special. We're not even particularly large. We're just here, in a small galaxy, in a small corner of an enormous universe. But here's the thing, that doesn't make us worthless. If anything, it makes us more valuable. Because in all this vastness, as far as we know, Earth is the only place where life exists. We might not be alone in the universe, but we're certainly rare. And conscious, intelligent life, capable of understanding all this, that might be rarer still. You are made of atoms that were forged in stars that died billions of years ago. Those atoms drifted through space, eventually coming together to form the Earth. And then, through billions of years of evolution, those atoms organized themselves into you. You're a way for the universe to know itself. Out of all the countless planets in all the galaxies across all of space, you're here, able to think about these questions. The Milky Way might be small compared to the universe, but it's your home. Every star you can see belongs to it. Every constellation, every myth and story humans have told about the night sky for thousands of years, all of it comes from our spiral. And here's the beautiful paradox we've been building toward. The Milky Way is simultaneously one of the largest galaxies in the universe and incredibly small compared to the largest cosmic structures. Both of these things are true at the same time. When we compare the Milky Way to most galaxies, to the dwarf galaxies that make up 95% of all galaxies in the cosmos, the Milky Way is enormous. It's a giant, a massive spiral containing hundreds of billions of stars. Most galaxies will never be this large. Most galaxies are tiny collections of a few billion stars or less, faint and unremarkable. The Milky Way is exceptional. It's in the top 5% of galaxies by size. That's genuinely impressive. But when we compare the Milky Way to the largest galaxies, to the supergiant ellipticals like IC 1101, then yes, it's smaller. And when we zoom out even further, when we look at superclusters and cosmic filaments and the observable universe itself, the Milky Way becomes just one galaxy among trillions. A large galaxy, yes, but still just one piece in a structure so vast, it defies comprehension. This is the true scale of the Milky Way. It's not small, it's not average, it's large, genuinely large by any reasonable standard. But the universe is so vast that even a large galaxy becomes insignificant when you zoom out far enough. It's like being a tall person in a large crowd. You might be taller than 95% of the people around you. That makes you tall. But stand next to a skyscraper, and suddenly your height seems irrelevant. Both things can be true. You can be tall and also tiny, depending on what you're comparing yourself to. The Milky Way is our home. It's large, genuinely impressively large, larger than almost every other galaxy. But it's also a tiny speck in the cosmic web. Both truths exist simultaneously, and understanding this paradox is key to understanding our place in the universe.
Now let's shift gears and talk about what this all means for the question of life in the universe. With 2 trillion galaxies in the observable universe, and each galaxy containing anywhere from millions to trillions of stars, the total number of stars is absolutely staggering. Astronomers estimate there are about 200 billion trillion stars in the observable universe. That's a 2 followed by 23 zeros.
Many of these stars have planets. The Kepler Space Telescope showed us that planets are common, not rare. Most stars have at least one planet, and many have several. If even a tiny fraction of these planets are capable of supporting life, the numbers become enormous. If just 1 in every million planets can support life, that's still 200 trillion potential homes for life. And if intelligent life arises on just 1 in every million of those life-bearing planets, that's still 200 billion civilizations in the observable universe. 200 billion civilizations. Yet we've never detected a signal from any of them. The galaxy seems silent. This is the Fermi paradox, and it's one of the deepest mysteries in science. Where is everybody? Maybe life is rarer than we think. Maybe the jump from simple life to complex life is incredibly difficult. Maybe intelligent civilizations destroy themselves before they can spread across the stars. Maybe they're out there but staying quiet, either by choice or because they're using communication methods we can't detect yet. Or maybe, and this is the humbling possibility, space is just too big. The distances between stars are so vast that even if civilizations are common, they might never encounter each other. The Milky Way is 100,000 light-years across. A radio signal from the other side of the galaxy would take 100,000 years to reach us. By the time it arrived, the civilization that sent it might be long gone. And if civilizations are spread across all 2 trillion galaxies, the nearest large galaxy, Andromeda, is 2.5 million light-years away. A signal from there would take 2.5 million years to reach us. Most galaxies are billions of light-years away. The universe is so large that civilizations could exist in enormous numbers and still never make contact with each other. They could be shouting into the void, and their signals would simply never reach anyone else before dying out. The scale of the universe isn't just humbling, it's isolating. Even if we're not alone, we're effectively alone, because the distances are simply too great to bridge. Think about that. The Milky Way might contain thousands or even millions of civilizations, but if they're spread across 100,000 light-years, they might as well be in different universes for all the interaction they'll have. This is what cosmic scale does. It doesn't just make us small, it makes us alone. But there's another side to this. If life is rare, if Earth really is one of the only places in the universe where life has arisen and become conscious, then we're not insignificant at all. We're incredibly precious. In a universe of 2 trillion galaxies containing hundreds of billions of trillions of stars, life might exist in only a handful of places. Maybe only here. That would make Earth, this small planet orbiting an ordinary star in a large galaxy, the most important place in the entire cosmos. Because we're the only ones who know it exists. We're the universe looking at itself. We're the cosmos becoming aware of its own existence. That's not insignificant. That's miraculous. Let's talk about the future. Because even though the Milky Way is small compared to the universe, it has a long story still to tell. In about 4.5 billion years, the Milky Way will collide with Andromeda. I say collide, that it's really more of a merger. The 2 galaxies will pass through each other over the course of several billion years.
Despite there being hundreds of billions of stars in each galaxy, actual collisions between individual stars will be rare. Stars are so far apart that most will pass by each other without incident. But the gravitational interactions will completely disrupt both galaxies' spiral structures. Computer simulations show what will happen. The two galaxies will approach each other, pass through each other, and then fall back together. They'll do this dance several times, each pass stripping away stars and gas until finally they settle into a single, large, elliptical galaxy. Some astronomers have nicknamed this future galaxy Milkomeda, or Milkdromeda. By the time this merger is complete in about 6 billion years, the result will be a galaxy much larger than the current Milky Way. Milkomeda will contain all the stars from both galaxies, roughly 1.5 trillion in total. It will be a giant elliptical, one of those large red galaxies that have stopped forming new stars. But even Milkomeda won't be that special. It'll be one giant elliptical among many others in the universe. Larger than the current Milky Way, sure, but still small compared to galaxies like IC 111. The merger will also bring us closer to some of the other galaxies in the local group. The whole group will eventually collapse into a single structure over tens of billions of years. This is the fate of galaxy clusters. The largest galaxies consume the smaller ones, growing larger while the small galaxies disappear.
But there's another future to consider. The universe is expanding, and that expansion is accelerating. Distant galaxies are moving away from us faster and faster. Eventually, billions of years from now, they'll be moving away so fast that their light will never reach us. The observable universe will shrink. Far in the future, any intelligent beings living in Milkomeda will look out at the sky and see nothing beyond their own galaxy. All other galaxies will have been carried away by the expansion of space, beyond the observable horizon. They'll be completely isolated, unable to see that the universe is larger than their galaxy. In a way, those future astronomers will be back where humanity was a few centuries ago, thinking their galaxy is all there is. Except they'll be right, in a sense. For them, the observable universe will consist of just one galaxy. Everything else will be forever beyond their reach. They'll never know about the cosmic web, about superclusters, about the 2 trillion galaxies that once filled the sky. They'll be alone in a dark universe, with no way of knowing that it was once filled with light. This is the ultimate consequence of the universe's expansion. Eventually, every galaxy cluster will be isolated, surrounded by darkness, unable to see beyond itself. The Milky Way's future is to merge with Andromeda, forming a larger galaxy that will then slowly drift into isolation as the universe expands around it. It's a lonely future, but it's billions of years away. For now, we can still see the cosmic web. We can still study distant galaxies. We can still marvel at the scale of the universe. And that's a privilege that won't last forever. Let me give you our full cosmic address, because understanding where we are in the universe helps put all of this into perspective. We live on Earth. Earth orbits the Sun. The Sun is located in the Orion Spur, a minor spiral arm of the Milky Way. The Milky Way is a large spiral galaxy, 100,000 light-years across, containing between 100 billion and 400 billion stars. The Milky Way is the second largest member of the local group, which contains about 50 galaxies and spans 10 million light-years. The local group is part of the Virgo Supercluster, which contains at least 100 galaxy clusters and spans 110 million light-years. The Virgo Supercluster is part of Laniakea, a supercluster of superclusters containing about 100,000 galaxies spread across 520 million light-years. Laniakea is one structure among many in the cosmic web, a vast network of filaments and voids that fills the observable universe. The observable universe is 93 billion light-years across and contains approximately 2 trillion galaxies. And beyond the observable universe, we don't know. The actual universe might be much larger. It might even be infinite. That's our address. That's where we are. Now think about what that means. Every time you look up at the night sky, you're looking at your cosmic neighborhood. Every star you see is part of the Milky Way. Every constellation belongs to our galaxy. That band of light stretching across the sky, the Milky Way itself, is the combined glow of billions of stars too distant to see individually. Ancient cultures created myths about it. The Greeks thought it was milk spilled by Hera. The Norse thought it was the path to Valhalla. Native American tribes saw it as a path of souls traveling to the afterlife. Chinese astronomers called it the Silver River. We didn't know what it really was until relatively recently. But even in our ignorance, we recognized its beauty. We told stories about it. We wondered about it. Now we know what it is. We know it's a galaxy, one of trillions. We know where it fits in the large-scale structure of the universe. We know how small it is compared to what's out there. But that knowledge doesn't make it less beautiful. If anything, it makes it more beautiful, because now we understand what we're looking at. We know that each point of light in that band represents another sun, perhaps with planets, perhaps with life. The Milky Way is small compared to the universe, but it's ours. And within it, on one small planet orbiting one ordinary star, life arose. Consciousness emerged. And now, 13.8 billion years after the Big Bang, the universe has produced beings capable of understanding their place in it. You are here, right now, able to comprehend the scale of the cosmos. You can hold in your mind the paradox of the Milky Way, that it's simultaneously one of the largest galaxies and also tiny compared to the universe. That's remarkable. That's precious. The Milky Way gave us a home, a stable, quiet corner of the universe where life could develop and thrive for billions of years. Without the Milky Way, we wouldn't exist. Without its spiral structure, its mix of old and young stars, its location in a relatively calm region of space, Earth might never have formed, or life might never have survived.
So yes, the Milky Way is small compared to the universe, but it's also everything we have. It's home. And sometimes, home is enough. Let's talk about how astronomers figured all this out, because measuring distances in space is incredibly difficult. You can't just stretch a ruler from here to another galaxy. Instead, astronomers use a series of techniques called the cosmic distance ladder. For nearby stars, within a few thousand light years, astronomers use parallax. As Earth orbits the Sun, nearby stars appear to shift slightly against the background of more distant stars. By measuring this shift, you can calculate the distance. It's the same principle you use when you hold your finger up and look at it with one eye, then the other. Your finger appears to move against the background. For more distant objects, astronomers use standard candles, objects whose intrinsic brightness is known. Cepheid variable stars, for example, pulsate with a period that's related to their luminosity. By measuring how bright a Cepheid appears and knowing how bright it actually is, you can calculate its distance. For even greater distances, astronomers use Type A supernovae. These exploded stars all have roughly the same peak brightness, making them excellent distance markers. They're so bright that they can be seen billions of light years away. The Hubble Space Telescope revolutionized distance measurements by observing Cepheid variables in distant galaxies. Hubble allowed astronomers to measure the distances to galaxies tens of millions of light years away. The James Webb Space Telescope, launched in 2021, is pushing these measurements even further, observing some of the most distant galaxies ever seen, galaxies that existed when the universe was less than 1 billion years old. But here's the thing, all these measurements have uncertainties. The distance to Andromeda, for example, is known to be about 2.5 million light years, but that number has an uncertainty of about plus or minus 100,000 light years. For more distant objects, the uncertainties get larger. When we say the observable universe is 93 billion light years across, that's based on models of how the universe has expanded since the Big Bang. We can't directly measure distances that large. We infer them from other observations. The point is, astronomy is hard. Measuring the vastness of space requires careful work, sophisticated instruments, and mathematical models. And even then, there's uncertainty. But despite these challenges, astronomers have built up a consistent picture of the universe's scale, and that picture shows clearly that the Milky Way is just a tiny part of something much, much larger. We also can't talk about the universe's scale without mentioning dark matter and dark energy, because these invisible components make up most of the universe. Normal matter, the stuff that makes up stars, planets, and us, accounts for only about 5% of the universe's total energy content. Dark matter makes up about 27%. We can't see it directly, but we can detect its gravitational effects. Galaxies rotate in ways that only make sense if they contain much more mass than we can see. Galaxy clusters are held together by gravity that's stronger than what the visible matter alone could produce. Dark matter provides the extra gravity. The Milky Way has a dark matter halo that extends far beyond its visible stars. This halo contains about 10 times as much mass as all the visible matter in the galaxy. Without dark matter, the Milky Way couldn't exist. The stars would fly apart. The galaxy wouldn't hold together. When we compare galaxy sizes, we're really comparing their dark matter halos as much as their visible components. A galaxy like IC 1101 isn't just 60 times larger in visible stars. It's also surrounded by a dark matter halo that's proportionately larger, containing proportionately more mass. Dark energy is even stranger. It makes up about 68% of the universe's energy content, and we have almost no idea what it is. We know it exists because the universe's expansion is accelerating. Something is pushing space apart, and that something is what we call dark energy. Dark energy is causing distant galaxies to move away from us faster and faster. Eventually, it will tear apart even gravitationally bound structures like galaxy clusters. Billions of years from now, dark energy might even overcome the gravity holding galaxies together, ripping them apart star by star. This means that even though the Milky Way seems small compared to the universe now, it might be relatively larger in the future. As dark energy pushes structures apart, making the universe less dense, galaxies like the Milky Way will become more isolated. In the far future, the Milky Way and its merged form with Andromeda might be one of the few remaining structures in a vast, empty universe. But that's billions of years away. For now, the universe is still full of galaxies, superclusters, and cosmic structure, and the Milky Way remains a small but significant part of that structure.
So, what does all this mean for us practically? Does it matter that the Milky Way is small compared to the universe? Does it change anything about our daily lives? In one sense, no. You still have to go to work, pay bills, deal with the same everyday problems as always. The fact that the universe is vast doesn't change any of that. But in another sense, yes. Understanding our place in the universe changes how we see ourselves and our world. Every boundary we've ever fought over, every disagreement we've ever had, plays out on a planet orbiting one star among hundreds of billions in a galaxy that's one of trillions. The astronomer Carl Sagan talked about this when discussing the pale blue dot photograph. That picture showing Earth as a tiny speck in a sunbeam taken from the edge of the solar system by Voyager 1. Sagan said that everyone we love, everyone we know, every human who ever existed lived out their lives on that speck. All our triumphs and tragedies, all our wars and peace, all of it happened on that one small world. And that world orbits a star in a galaxy that's small compared to the universe. This perspective doesn't make our lives meaningless. If anything, it makes them more meaningful because we're here, able to understand all this. We're the universe becoming aware of itself.
The Milky Way might be small, but it's your home. And as far as we know, Earth might be the only place in this vast universe where life has arisen and become conscious. That makes us precious, not worthless. There's something profound that happens when you truly grasp the scale of the universe. It changes you, not in some vague, mystical way, but in a real, practical sense. Your perspective shifts. The problems that seemed overwhelming yesterday suddenly seem smaller, not because they're not real or important, but because you see them in context. That argument with a friend, that stressful day at work, that disappointment you've been carrying, all of it is happening on one planet, in one solar system, in one galaxy among trillions. This isn't about minimizing your problems. Pain is pain, and suffering is suffering, regardless of cosmic scale. But there's something freeing about understanding that the universe doesn't revolve around your personal drama. The cosmos will continue its slow, majestic dance whether you succeed or fail at whatever you're trying to do. At the same time, this perspective makes moments of joy, love, and connection more precious because they're rare. As far as we know, Earth is the only place where life exists, and conscious life, capable of love and art and music and wonder, that might be even rarer. Every human interaction, every moment of beauty, every act of kindness is an extraordinary thing, not because some divine plan says so, but because it's genuinely unusual in a universe that's mostly empty space and unconscious matter. The Milky Way might be small, but it produced you, and you can love, think, create, and wonder. That's remarkable. Understanding the true scale of the Milky Way, one of the cosmic giants, yet just one island among trillions, should make us cherish Earth even more. We talk about climate change, vanishing species, the fragile balance of our world. Sometimes these challenges feel distant, almost abstract. But pause and remember, as far as our telescopes can see, Earth may be the only place where oceans reflect sunlight, where forests breathe, where minds like yours have awakened beneath an open sky. In a universe of silent voids and burning stars, this pale blue dot is the only home we've ever known, possibly the only one conscious life will ever have. We won the greatest lottery of all simply by being born here in a stable corner of one of the universe's grandest galaxies. Liquid water, breathable air, a magnetic shield against the solar wind, a climate gentle enough for billions of years of evolution. These are not ordinary things. They're miracles wrapped in everyday light. And now, for the first time in cosmic history, the actions of one species on one small world can decide whether this miracle continues. That's not a burden, it's a privilege, a quiet, immense responsibility carried by stardust that learned to care. Our Milky Way is vast and magnificent, home to hundreds of billions of suns, yet Earth is infinitely precious within it. It's the only place we have, perhaps the only place anyone ever will have. That alone is reason enough to protect it, not out of fear, but out of wonder, gratitude, and love. Think about what we've learned tonight. The Milky Way is genuinely large by cosmic standards, bigger than 95% of all galaxies. That's impressive. But it's also small compared to superclusters, cosmic filaments, and the observable universe. That's humbling. Both truths matter. Both are real. And both should inform how we live. We should feel pride in living in such a remarkable galaxy. We should feel wonder at the cosmic structures that surround us. We should feel curiosity about what lies beyond our observable horizon. But we should also feel responsibility for the one planet we know supports life, the one world where consciousness emerged, the one place that matters more than all the galaxies combined because it's home.
The universe is vast and filled with wonders, but Earth is unique, and that makes it worth protecting.
Astronomers are still discovering new things about the universe's scale. New telescopes are being built. New observations are being made. Our picture of the cosmos continues to evolve. The James Webb Space Telescope is already sending back images of galaxies that existed when the universe was very young, less than 1 billion years after the Big Bang. These early galaxies are smaller than the Milky Way, often by a lot. They're the building blocks that merged over billions of years to form the large galaxies we see today. Studying these distant galaxies helps us understand how the Milky Way formed. Our galaxy didn't spring into existence fully formed. It grew over time, consuming smaller galaxies and gathering mass. The Milky Way we see today is the result of 13 billion years of evolution. Future telescopes will see even further. Plans are being developed for instruments that can observe the very first stars that formed in the universe. These observations will help us understand how structure formed, how galaxies grew, and how the universe evolved from a nearly uniform soup of hydrogen and helium into the rich tapestry of galaxies we see today. But no matter how powerful our telescopes become, we'll always be limited by the observable universe's boundary. We can never see beyond that horizon. The universe beyond our view will remain unknown, possibly forever. Still, the search continues. Because even though the Milky Way is small, even though we're just one tiny part of an enormous universe, we want to understand it. That drive to explore, to question, to seek knowledge is one of the things that makes us human. We look up at the stars and we wonder. We build telescopes and we search. We create theories and we test them. And slowly, piece by piece, we figure out our place in the cosmos. The Milky Way might be small, but it produced beings capable of asking these questions and seeking answers. That's something to be proud of. There's a paradox at the heart of everything we've discussed tonight, and I want to make sure you understand it. A seed is tiny, almost nothing, yet from it grows a tree that can outlive mountains. An atom is unimaginably small, yet atoms build stars, worlds, and you. The Milky Way sits in that same perfect balance. Vast enough to cradle hundreds of billions of suns, stable enough for life to arise, rich enough in heavy elements for planets and consciousness to emerge. Within this one extraordinary galaxy, at least one world learned to look back at the sky and understand what it was seeing. The universe may be incomprehensibly large, but most of it is silent and empty. Our Milky Way, exceptional in its size, remarkable in its story, is different. It has us. When you compare the Milky Way to dwarf galaxies, to the countless small collections of stars that make up most of the universe, we're giants. When you compare the Milky Way to superclusters and cosmic filaments, we're tiny. Both perspectives are valid. Both are true. The Milky Way is simultaneously one of the largest galaxies in the universe and also incredibly small compared to the largest cosmic structures. Understanding this paradox, really understanding it, is what it means to grasp the true scale of our cosmic home. We're not insignificant. We're exceptional. We live in a galaxy that towers over most others. But we're also part of something incomprehensibly larger, structures that span billions of light years, a universe containing trillions of galaxies. Hold both truths in your mind. That's the key. The Milky Way is large, the universe is larger, and you, living in this remarkable galaxy, are part of it all. Let's zoom back in. Let's come home. Because no matter how small the Milky Way is compared to the universe, it's still our galaxy. It's still home. When you go outside tonight and look up at the night sky, try to see the Milky Way. It's harder if you're in a city because light pollution washes it out. But if you can get somewhere dark, away from streetlights and buildings, you'll see it. A pale band of light stretching across the darkness. That's your galaxy. That's where you live. All those points of light, all those stars, they're your neighbors in space. Some are closer, some are farther, but all of them are part of the same structure that holds you. Every star you can see with your naked eye is part of the Milky Way. Sirius, the brightest star in the night sky, is about 8.6 light-years away. Betelgeuse, the red giant in Orion, is about 700 light-years away. Alpha Centauri, the nearest star system to our Sun, is about 4.3 light-years away. All of them are our neighbors in this vast spiral. The Milky Way has been humanity's companion for as long as we've existed. We've looked up at it, told stories about it, wondered about it. And now we understand what it is.
We know it's a galaxy, one of trillions. We know where it fits in the universe's large-scale structure. We know how small it is compared to what's out there. But that knowledge doesn't diminish its beauty. If anything, it enhances it. Because now when you look at that band of light, you know what you're seeing. You know each point of light is another sun, perhaps with planets, perhaps with life. You know you're looking at one of the largest galaxies in existence, a cosmic giant home to hundreds of billions of stars. And you know at the same time that it's just one galaxy among trillions, one structure in a universe so vast that it challenges comprehension. Both things are true. The Milky Way is large and small, exceptional and ordinary. Your entire world and just a tiny speck. And that's perfect. Because the Milky Way gave us everything. A stable home for billions of years, a quiet corner where life could develop, a place where consciousness could emerge and look back at the stars. The question we started with was, what is the true scale of our Milky Way in this vast universe? And the answer is breathtaking. Zoom in and we live in one of the cosmic giants, a galaxy so large that 95% of everything else out there is smaller. Zoom out, and even our mighty spiral becomes just one flickering light in an ocean of 2 trillion others. That duality is everything. The Milky Way gave us hundreds of billions of stars, a quiet corner stable enough for life to appear, and 4 billion years of calm evolution that let consciousness emerge on one little world. Every human story, every love, every dream, every discovery, all of it unfolded here, inside this one extraordinary galaxy. The universe is unimaginably large. Countless superclusters, walls, and voids stretch farther than light has had time to travel. Yet you are here, right now, awake inside one of the biggest islands in that endless sea, feeling the full weight and wonder of it all. So when you look up tonight at that glowing band across the sky, remember, it's vast enough to be exceptional and still just our home. And that makes it perfect. Thank you for joining me on this journey tonight. If you found value in this exploration, please hit that like button and subscribe. Your support genuinely helps me continue making these deep dives into the cosmos. And remember, the next time you look up at the night sky and see that band of light stretching overhead, you're looking at home, one of the largest galaxies in the universe. Genuinely, impressively large,
home to hundreds of billions of stars. And yet, when you zoom out far enough, just one galaxy among trillions in a cosmos so vast, it challenges comprehension. The Milky Way is large, the universe is larger, and you, living in this remarkable galaxy, are part of it all. Sleep well under the stars. The Milky Way is vast, and you have your place in it, right here, right now, in this large, precious galaxy we call home.